Hi, what's up people? Mr. Highway here. Today I'm going to share with you about the differentiation of trigonometric functions. And we have this. Differentiate sine x is equals to cosine x. Differentiate cosine x is negative sine. So if you keep differentiating, you get sine, cosine, cosine, sine, right? However, when you differentiate tangent x, you get a secant square x, which is something quite different. Now the x here is taking the sine, right? However, if your angle here that's taking the sine is a multiple angle, right? That means it's not 1x, it's 2x, 3x or whatever. Then you will have to apply your chain rule, okay? So you can watch my other video on chain rule. Basically, you ask yourself, which are the parts that can be differentiated? And when we look at this, we see that the sine operator gets differentiated and the ax is like a polynomial, okay? It gets differentiated as well. If you differentiate ax, the angle, then you get a. And it's multiplied, right? We always do a multiplication in differentiation. And when you differentiate sine, you get a cosine. But remember this, that the angle doesn't change as a result of differentiation. So you just get cosine ax. So in the same way, if you differentiate ax, the angle, you get an a. Differentiate cosine, you get negative sine. So I'll put a negative outside, you have negative a sine ax. Again, the angle doesn't change as a result of the differentiation. Differentiate the angle, you get a again, but differentiate tangent, you get secant square ax. How about if the angle goes like ax plus b? It's an expression in itself. You have ax plus b, a linear expression. Then you differentiate ax plus b, you multiply the result in front, and the result is a, right? When you differentiate ax plus b. And when you differentiate sine, you get cosine. So it's the same thing, cosine of angle no change. Okay, remember that, ax plus b. Differentiate cosine is negative sine, differentiate ax plus b is a. So you have negative a sine bracket ax plus b. So in the same way, when you differentiate tangent, you get secant square, you differentiate ax plus b, you get a. So you have a secant square bracket ax plus b. Something to take note of is that any angle associated with differentiation of trigonometric functions, and later in integration as well, is always in radians. So differentiation and angles in degrees do not mix. You always get angles in radians. Example 1, differentiation of trigonometric functions. So now let's differentiate part A, d dx. Okay, I'll write the operator here first. d dx of 2 sine bracket 3x plus pi over 2. Now, in some places, this expression that's going to take the differentiation will get another pair of brackets, but it's not really very serious. Okay, I think it's fine if you don't put it. But if you want to be safe, then yeah, sure, why not put it. So here we have two things to differentiate. First the angle, and then the sine, right? So let's look at this. We differentiate the angle, 3x, you differentiate, you get a 3. Pi over 2 is a constant, you differentiate, you get 0. So you just have a 3 here. And the 2 is unaffected during the differentiation, so I'll just leave it as 2. Differentiate sine is cosine, and the angle no change. So we still have 3x plus pi over 2. So 3 times 2 is 6, and you have 6 cosine of 3x plus pi over 2. Alright, that's it. Part B, 3x squared tangent 5x. Okay, so in this question we have product rule. Okay, so we're going to let u, let v. We let u to be equals to the first part here. So you see 3x squared is an expression in and of itself that is multiplied to the other function here, which is tangent 5x. So if we let u to be equals to 3x squared, then we let v equals to tangent 5x. Then we differentiate each one. du dx is 2 times 3 is 6, and we have x here. Differentiate v, dv dx. Differentiate the angle, you get a 5. Differentiate tangent, you get the secant squared. Angle no change, remember that. Okay, then we do this, differentiate the first times the second, plus differentiate the second times the first. So we will have dy dx to be equals to 6x times tangent 5x plus differentiate the second 5 secant squared 5x times 3x squared. Simplify it and we are good. And do any factorization if it's possible. Immediately I see that 3x is a common factor, so I'm going to write it outside here. Differentiate. We factor out 3x from 6x is 2, and we have 2 tangent 5x plus, okay, 3 comes out, x comes out, we are left with x, and we have 5x secant squared 5x. Okay, that's pretty much it. So now I'm going to share with you 2 questions. You give it a try and share your answers in the comments below. Let me see if it's correct. Next, we talk about derivatives of trigonometric functions with higher powers. So we have an example here. We're going to differentiate sine cube 5x. So now let's see again what are the things that we can differentiate. Okay, so first we have to differentiate the power. The second thing, we will differentiate sine. And the third thing, 5x. So let us write it down. We differentiate the power first. Then we differentiate the sine. Or maybe in other question, it can be cosine or it can be tangent. And then we differentiate the angle finally. Okay, so let's look at this example. See how we will differentiate sine cube of 5x. Now, before we even start, I want you to know that the differentiation of sine cube 5x is the same as differentiation of sine 5x to the power of 3. So when we deal with this power here, we bring down the power minus 1, okay? So we will have 3 of whatever it is here, and then power 3 minus 1, isn't it? And whatever in here is actually the sine of 5x, okay? Once we differentiate the power, we don't look at it anymore. We look at what's inside there that's taking the power, and we differentiate it. If you differentiate sine 5x, yeah, then you differentiate the angle, you get 5. Differentiate the sine, you get cosine 5x. So we have 3 here, we have 5 here, and it's 15. Sine 5x to the power of 2, so it's sine square 5x. Okay, the 5 went to the front and we have a cosine 5x over here. And that's it. Example 2, differentiation of trigonometric functions with powers. So now we are going to d dx differentiate with respect to x. 3 sine 4x plus 2 cosine square 3x. Now in this case, you must put the square brackets. Okay, if you don't, then it would be just the differentiation of 3 sine 4x. Okay, so it's important, because this is a plus here, it's important that we put the square brackets to make it clear that we are differentiating these 2 terms, both terms, not just the first one. We bring down the power 4 and the power minus 1, right? So we have 3 sine. Power 4 minus 1 is power 3x. Then we differentiate the sine x without the power. Differentiate sine x is cosine x. Plus, again, the power. So the power 2 bring down, 2 times 2 is 4. And you have cosine squared becomes cosine power 1, right? 3x. Differentiate cosine is negative sine 3x. And then we differentiate the angle. We can leave it here. Okay, let me just write it over here, which is actually a minus, isn't it? Then 4, 3 is 12. Cosine 3x, sine 3x. Okay, so we have 4, 3, 12 sine cube x cosine x minus 12 cosine 3x sine 3x. Right, that's it. And typically for differentiation questions, it's important to do the factorization. So let's do that now. And 12 is a common factor. 12 is a common factor, but this sine qx, sine 3x, okay, they are not the same. So we can't factor it out. All that we have would be 12 of sine cube x cosine x minus cosine 3x sine 3x. And that's it. Part B, we're going to differentiate with respect to x for tangent cube of x over 2 plus pi over 3. Okay, power bring down. 4 times 3 is 12. Tangent cube power minus 1 becomes squared. And then x over 2 plus pi over 3. Okay, I know I've sped up, but I want you to be able to think like this, okay, the way I do it. Because you always are racing against time. The next thing we have to differentiate is the angle, don't forget. So we're going to multiply by the differentiation of this whole thing. X over 2 differentiate is half. Pi over 3 differentiate is gone because it's a constant. The next thing to differentiate will be the tangent. Differentiate tangent is secant squared. Angle no change. And multiplied by the differentiation of the angle. The angle here, x over 2 differentiated is half. Differentiate pi over 3 is 0, so I'll just leave it. Alright, so then 12 times half is 6. And we have tangent square angle secant square, the same angle. Alright, that's it. So now you give it a try and share your answers in the comments below. So that's it for the differentiation of trigo functions. Depending on where you're learning this topic from, you can have a much more bigger variety of questions than what we shared here. Okay, so what we have here is just scratching the surface. It's meant to just get you to start off on this topic, understand the concepts. You're going to have to do a lot more practices to be good and be scoring A's. Share with me what questions you have in the comment section below, and maybe I can help you out with the homework a little. Alright, so that's it for this video. Like and subscribe. See you next time.